Hello, so here is my 5-minute poster presentation about my project. So note that the poster would have been printing out each of these slides and then taping them together to make a bigger poster. Alright, so the ontology consists of 4 items. So the application domain is the 26 most common and most commonly searched diseases. Originally there were going to be 50, but I got to fully flesh out 26. The concept in use in this project is that while some diseases have symptoms in common, given a detailed enough ontology and user information about the symptoms of the disease, the list of possible diseases can be reduced to just one disease. The relationships in this project are that diseases have symptoms and treatments. Symptoms have categories such as bodily areas, including gastrointestinal, muscular, and skin, while treatments have different types, such as supportive care, medication, and surgery. Symptoms would be something like a class. The disease would be a superclass, and treatments is also a class. And these examples of gastrointestinal, muscular, and skin, or supportive care, medication, and surgery would be instances of those classes. So the axiom in use is that diseases are unique and have symptoms unique to them. Problem-solving method has 4 steps. First, acquire knowledge and data about or an ontology about the domain. In this case, diseases and their symptoms. Acquire user input about the disease, such as an initial list, and through subsequent questioning. Based on the initial information, eliminate unlikely diseases or diseases that do not match the given symptoms, and then repeat steps 2 and 3 until the list of diseases contains one disease. Evaluation methods include the 4 that we focused on in lecture. Formatively, the project could include future utilization of Google Knowledge Graph API, future utilization of OWL API, and ontology refinement. Summatively, although the logic of the evaluator or classifier is almost completely well formulated, the ontology itself contains a little more than half of those 50 originally intended to be covered. Objectivistically, for the diseases in the current version of the ontology, the deduction process is almost guaranteed to produce the correct result given accurate user input. And subjectivistically, the lack of a pretty graphical user interface and therefore heavy reliance on the use of a Unix terminal makes this inaccessible to most people. So the results, this program performs one function well. It's that given a small user inputted list of symptoms, it asks the user more and more questions about the disease's symptoms until the singular disease is deduced. So in my remaining minute and 30 seconds, I will run through a demo of the program itself. So first it shows some random diseases in the ontology and some symptoms that you can use. So one symptom that a lot of diseases have is fatigue. And given that the user inputted fatigue, one symptom, gave a list of possible diseases based on the diseases in the ontology, and asks, is the symptom fatigue for over 6 months present? And let's say my disease I'm looking for is type 2 diabetes, and it would be no. Is increased thirst present? Yes. Diabetes makes you thirsty. Is no symptoms present? In some, I think it's type 2 diabetes, or yeah, type 2 diabetes, sometimes there are no symptoms. So now that we've eliminated all of the possible diseases based on what the user gave, it gives some treatment options for type 2 diabetes, which includes diet, exercise, medication, insulin therapy, and so on. So that is my project. Thank you for listening.